everyone, thanks so much for joining this video. We're going to look at some harder questions on the topic of redox. So number one is to use the half equations below to write the full redox equation for the oxidation of hydrogen by H plus / FeO42 minus. And so the first thing we do is look at the electrons. So we have 3 electrons here and 2 electrons here, which means that we need to times the second equation by 3 and the first equation by 2 in order to cancel out the electrons at the end. And so now we combine the two half equations. So we get 2 FeO42 minus plus 16 H pluses plus 6 electrons plus 3 H2O2, and that goes to form 2 Fe3 plus ions plus 8 waters plus 6 H pluses plus 3 oxygens and 6 electrons. So now we can cancel out the electrons because we have 6 on each side. But now we find that we can actually cancel out these H pluses too, because there are 6 on this side and 16 on this side. So if we cancel out 6 H pluses on each side, then this becomes a 10. And so the redox equation is actually 2 FeO42 minuses plus 10 H plus 3 hydrogen peroxides and then 2 iron 3 plus ions plus 8 waters and then plus 3 oxygens. And this is the full redox equation. So before I start on the second question, feel free to click off the video and try it yourself first. So chlorine is an important industrial chemical and is formed when potassium manganate reacts with hydrochloric acid. And the ionic equation for this redox reaction is below. Deduce the half equation for the oxidation of chloride ions to chlorine. And so remembering the rules, first of all, we write down the chloride ions on the chlorine. So we know that chloride ions form chlorine. And then we remember that, first of all, we need to balance out everything that isn't oxygen or hydrogen. So that is the chlorines. So that means we need another chloride ion on the left-hand side because we've got 2 chlorine atoms on the right-hand side. And then what we do is we balance the oxygens with by adding waters. We don't have any oxygens, then we move on to the next step, which is to balance the waters with H plus ions. And we also don't have waters, so we can skip that step as well. So then the last step is to add electrons to balance the charges. So on the left-hand side, we have a charge of -2, and on the right-hand side, we have a charge of 0. And so then that means that we actually need to add 2 electrons onto the right-hand side. It's conventional to write the electrons as pluses instead of minuses, because I could agree that if you wrote -2 electrons here, it would be the same thing. However, it is the convention to write +2 electrons instead of -2 electrons. And then for B, give the oxidation state of manganese in the MnO4 minus ion. So first thing you do is write out MnO4 minus, and then remembering one of our rules is that oxygen is nearly always -2. So we have -2 here, and we have 4 of them, so we have 4 -2s. And then we have an overall charge of -1, and we know that all the oxidation states have to add together to make the overall charge, which is -1. So if we call the manganese X, because we don't know what it is, we then have X minus 8 equals -1. And so therefore we have that X equals +7. So now we found our oxidation state of manganese, which is +7. And then for C, Deduce the half equation for the reduction of the MnO4- ions in acidified solution to manganese 2+ ions and water. So we start off with MnO4- ions, and then we leave a gap and reform Mn2+ ions. So first what you do is balance everything that isn't oxygen and hydrogen. So in this case it would be the manganese, and we can see that it's already balanced because we've got one on each side. And then we go to balance the oxygens by adding water. So we have 4 oxygens on the left-hand side, which means we need 4 waters on the right-hand side. And then the next step is to balance the hydrogens. So we have 8 hydrogens on the right-hand side. So we need to add 8 H pluses onto the left-hand side. And then the final step is to balance the charges by adding electrons. So on the left-hand side, we have a charge of -1 plus 8, which is +7. And then on the right-hand side, we have a charge of +2. So that means we need to add 5 electrons onto the left-hand side in order to get both sides to be equal to +2.